Hey everyone. In this mini lecture, we're going to be looking at derivatives of trigonometric functions. So first, just be sure that you have all of the derivatives of trig functions right next to you. Some type of reference sheet, reference page of notes, something that you can refer to, and we're just going to take a look at all of them. Well, maybe not all of them, but whatever ones we need in doing our examples. All right, so our first example says to find y prime, right? Find the derivative of this function y, which is equal to x squared minus sine x. All right, so I see two terms. I see an x squared term and a minus sine x term, right? Two terms, so that means I can apply the sum difference property. So I can go ahead and take the derivative of that x squared and then also take the derivative of the negative sine x, right? So I can take the derivative of that sine x as well. So taking the derivative of x squared, you know from previous study that you can apply the power rule, right? That was one of the first rules you probably learned for derivatives, one of those first shortcuts. So we get 2x. And then the derivative of sine x, if you just go back to the chart that I just displayed or your own notes for the derivative of sine x, which is cosine x. And there we have it. That's what y prime is. Okay, in this next example, we have e to the x sine x. E to the x sine x. So from what it looks like here, we have one function, e to the x, being multiplied times sine x, right? It didn't show that multiplication symbol, but we knew that to be multiplication. One function times another function. So it looks like we will have to go back into our toolbox and say, which formula do we use? We use the product rule for derivatives. So the product rule says, let's take the first function, just write the first function over. It's just e to the x, don't do anything to it. But then we're going to multiply that first function times the derivative of the second function, which is sine x. The product rule also says then we're going to add to that the derivative of the first function, right? So we're going to take the derivative of the first function and then multiply that times the second function. Okay, so this is an application of the product rule. And now we can go ahead and take the derivative. So then we have e to the x, that's the first function, but the derivative of the sine x, that second function, we know to be cosine x. And then the derivative of e to the x, well, this is another rule that you've probably already been given and you've already studied. E to the x has that special property where its derivative is still also just e to the x. So the derivative of e to the x is e to the x and then times sine x. Okay, and then lastly, we can go ahead and pull out an e to the x because that's what's common in both terms, e to the x. And then e to the x goes into that term on the left, cosine x times, and it goes into the term on the right, sine x times. So we can say y prime is equal to e to the x times the quantity of cosine x plus sine x. Okay, next example, sine x over x. Okay, so it looks like we have some division because of the fraction bars, so that tells us to use the quotient rule for derivatives. Okay, so the quotient rule, to find the derivative of a quotient, it says you take the lower function, and when I say lower function, I mean the one in the denominator. When I say higher function, I mean the one in the numerator. So it says to take the lower function and then multiply it times the derivative of the upper function. And then it says to subtract, right? Subtract then we're going to take sine x, which is the upper function, times the derivative of the lower function. And then we take all of that, put it above the lower function squared. Okay, so and next step, we're going to go ahead and say x times the derivative of that sine x, and we can just look on our chart that we were just reviewing, is cosine x minus sine x times the derivative of x is just 1. So we can just say that's still over x squared, and y prime will be for us x times cosine x minus sine x times 1 is just sine x, and this is all over x squared. All right, and this example says we have the function y is equal to cosine x over 1 minus sine x. Again, I see the fraction bar. That's telling me division, so we have a quotient. So I'm going to apply the quotient rule. So the quotient rule says to find the derivative, we're going to take the lower function, 1 minus sine x, right, that entire lower function, times the derivative of the upper function, derivative of cosine x. Then it says to subtract the upper function, cosine x, as you multiply it times the derivative of the lower function, which is that entire 1 minus sine x. We put that entire thing above 1 minus sine x squared. We always square that denominator in the quotient rule. Okay, so now we have 1 minus sine x, and then we're told to take the derivative of cosine x, which is negative sine x. Again, you can just refer to your sheet, or you could come to memorize these. And then that's minus cosine x times the derivative of 1 minus sine x. Well, 1 minus sine x has two terms, so we can use that sum difference property. The derivative of 1 is 0, right? And the derivative of sine x is cosine x. And this is all still over 1 minus sine x squared. All right, and in our next step, we can go ahead and multiply that negative sine x times those two, right? Negative sine x times 1 is negative sine x. Negative sine x times a negative sine x makes a positive sine squared x, right? And then we can do the same thing with this cosine x. Negative cosine x times 0 is 0. Negative cosine x times a negative cosine x makes a positive cosine squared x. And this is all over 1 minus sine x squared. All right, so now you have to be able to look at it further and say, aha, that looks like something special that's going on right there. So let's see what that is. So we think back to some Pythagorean identities, right? So if we have sine squared theta plus cosine squared theta, that's equal to 1. So that's what we have there. Instead of theta, of course, we have x. So I can write 1 instead of all of that. I can just write the 1, right? So let's write sine x plus 1 over 1 minus sine x squared. Maybe to make it look a little better so we can see it better, I'll move the 1 to the front. I'll move the 1 right to the front. So I'll move the 1 right to the front, so it'll be 1 minus sine x over 1 minus sine x squared. Well, there are two of them in the denominator and one in the numerator. So the one in the numerator will cancel out with one of them that's in the denominator. So that leaves a 1, and we'll still have 1 left. 1 minus sine x left in the denominator. So this will be our y prime. Our derivative is 1 over 1 minus sine x.